So I just pushed the wrong button. But the question Shaylee asked me. So again, the test is Monday, 6 o'clock. It will show up. If you have a printer, best I can answer you, Shaylee, you'll want to print it. So you can, for me personally, I like to be able to print, but not everybody has that ability. So then you'll have to do it on a piece of paper, looking at it on your screen. Really, it's the best we can do in this environment. And then no matter how you take it, then you'll have to scan and then submit the scan. I don't know if that's the question you were asking me. She's not here.
Yeah, that was the question.
Okay. And again, go ahead. I will have my office hour. I'll be on here by 5. The extra credit will be available tomorrow. I want to look at it because I might make a change to it. Because when I was looking at it, I thought I had made a change. And make sure you have a periodic table. Make sure you have a calculator, because right, I'm not there. And you can have a note sheet. Have a note sheet with your stuff so you don't have to look everywhere, including metric. And go back and redo your study sets. Redo this. Were you going to say something, Shaylee? Sorry.
No, you're good. You already answered it. I got you.
Yeah. Yeah, and I know, I recognize that some people have printers and some people don't. And so when I figure out the time right now, usually it's a 75-minute test. So I'm building in an extra 15 minutes for that time, like scanning and stuff. You guys should be pretty good at that. That should only take like maybe 5 minutes, or the printing time and stuff. So I build in some extra time for that. All right, let's go ahead and go through this. If you're studied, you should be fine. I will tell you, and if you want, go back and rewatch the videos. I had a student, and he was in my class in the winter term when we did everything in person. And he never finished my test. He was always the one I was going up to saying, hey, our time's up. It wasn't in this class. It was my 221. And actually in the summer, he would finish my test in half the time I was giving. And nobody else was. And it was because he started preparing very different. And everybody started asking him how he was preparing. And it was going back, and he redid everything. He rewatched the videos. He would stop the videos and try stuff. And then he just put the time in, and he did amazing on all the tests. So, all right, atomic number. You guys know how to do this. So sulfur is 16. A reminder, this chart is all whole numbers. So whole numbers. We're counting particles. So this chart, we're not using the number underneath. So sulfur here has to be the number I give you for the mass. It's the specific isotope. Protons are 16, electrons are 16, and then we subtract to get 19 neutrons. Oh, I know what I was going to mention. The lecture Monday, I'm going to pre-tape it, and it will become available like after the test. So you can watch it on Tuesday. I've always had it, like they always had a lecture after the test. And the study set is not a tough study set in the worksheet. But what we do Wednesday next week, you want to have that where you feel really good with it, because what we do Wednesday can be challenging for some students. All right, element number 18 is AR, which is argon. Mass number, we would add these two. So remember, your mass number is your protons plus your neutrons. So going back over the study sets, so it's fresh. And then this last one, the electrons, you want to make sure that this then equals our 136, which it does. And element 56, I'm pretty sure is barium. Yep. So Ba is barium. And the atomic number would be 56. Now, what if I had, just to review, because somebody will ask, had actually only given you 54 electrons. You can get the protons, though, from the mass number and the neutrons, but this means you lost 2 electrons. So don't add or take away electrons. It's only if I did something like that. This is a question that came up on something, I think on the worksheet, and it was where it had an extra electron. In this case, when you lose electrons, the barium has extra positives, so we'd say +2. But again, don't do that unless I do it, or just be like, you know what, that's gonna make 1 point difference, just move on. All right, and I don't even know if we'll see something like that. So subatomic particles, same as a proton, would be a neutron. Isotopes have the same number of protons, different neutrons. Similar to nitrogen, you have your choice. So phosphorus, arsenic, antimony, bismuth, so same family. Somebody's not muted. I don't know who it is, though. It's always a mystery. Metalloid and period 2, there is only one answer. So period 2 would be our second row. So period is row, and the metalloid is boron. All right, halogens, the 17th family, or 7A, third. So there is nothing in the first row. So second would be fluorine, third row would be Cl or chlorine. And then copper, remember this question? This was only 2 weeks ago. So we find copper on the periodic table, and 63.55 is the average mass. And so it's always closer to the more stable. So 63 is the more abundant. Before you write it on the blank, make sure that's the question I asked. Because the one I think that was on the worksheet, I had asked which one, how many neutrons. So I do just ask, and so you would say copper 63 is the more abundant because it's closer to the average. So they all have many different isotopes. All right, family names and valence electrons. So cesium is in the first family. So these are the alkali metals. 1 valence. So always 1 after the noble gas. Strontium is the earth metals. I'm just writing too big. And it is 2 valence electrons. Bromine, these guys are the halogens. And they have, you can say 17 or 7 valence. I would accept either answer. And then the noble gases, again, you can say 18 or 8 valence electrons. I'll get over our difference in periodic tables. Some people will even say for the noble gases it's 0, because the term of valence electrons is how many electrons in the unstable after the noble gas. And so there's nothing unstable about them. So some people will say 0, which is fine. In fact, some periodic tables put a 0 in that family. So I won't ask that question because of that difficulty. All right, so beta decay. So PB 214 is on this side of the arrow. The beta particle is on this side. You guys remember your beta particle? So just go back over. You guys did great with this when we did it. It's just been, sorry, the mass number doesn't change we find PB's atomic number 82, and it moves up to 83, which will be bismuth. All right, PA it's a large number, and it's down here right next to uranium. So it's number 91. So again, the decay, the alpha or beta particle are after the arrow. We lose 227. So 4 plus 2, 27. And then this would now drop down to 89. And you find 89, which is AC. All right, filling in the blanks, we just fill in our lower numbers. You'll probably also see a half-life question that was on our worksheet, and the arrow, we just think of it as an equal sign. So 18 on top, so this needs to be a 17, and 9 on the lower numbers, so this needs to be an 8, and that's oxygen. And that's going to react because that's not going to be stable because it's not near the average on the periodic table. All right, potassium is 19, argon is 18. It is not beta. This one is a positron. All right, and then that one where it goes through multiple different types. So we have thorium 232 and 90, and you can show all the different, you can show them all separate, or you can put that there's 2 alphas and 2 betas. For a lot of you, it will be easier to see them as 4 separate particles because they truly are. So the mass is going to change by 8. So this is now going to be 224. And the atomic number is going to change by 2. So it's going to be 88. You can ponder that, which is radium. And it will keep going. So these all have like 14 steps in their decay. And yeah. All right, any questions from the first page? Keep going. See, math. It's just one page. The whole thing is not math. Traditionally, I put the math first because actually it calms people. I don't know. Or maybe we'll do quantum first because it'll be the freshest in your mind. So you find phosphorus on the periodic table, and previous noble gas would be neon. And then we're in the third row, and we go 3s2, 3p3. There's my S, my 3s, and my 3p. And you want to bracket it, and they are 3 separate electrons. We can switch to blue now. Iron is Fe, so it's number 26. So we're going to start with argon. 4s2, 3d6. That argon's 18, so 18 plus 2 and 6, so it works out. So back to the question Katie asked me, and I'm asked every year, why does it become 3D? It's just how it is. The Ds, again, are really energetic, so they always knock up higher. All right. Each of them gets 1 electron before any of them pairs up. And tin is a sin. So number 50, which is actually part of the island of stability. So tin, we would start with krypton, which is number 36. And so on your test, don't rush. You want to have a clock also, or a watch or something, so you can keep track of time. But you should be, you study, you'll be fine. So after the 5s, we go through the 4d, and then to get to tin. So for tin, this is the end of the 4ds, are from yttrium to cadmium, and then 2 electrons. All right, you will be showing both the NLX, again, that's what I'm calling this, so with the noble gas and the box and arrows. So the 5s. And SPDF 1357. I do tend to put the test in an order. Not necessarily the order we did it in class, but kind of like this handout. So that's a good thing. All right, my 4Ds are going to be filled. Reminder for full credit, you do want to bracket the ones that go together. So you're showing me you understand those 5 go together. And then your P's. You show all 3 orbitals, but only 2 electrons. Those 2 electrons go in separate orbitals and spin the same way. So they either both spin up or both spin down. And just a reminder, that is a classic way chemists show and physicists half arrows. You can show full arrows, that doesn't matter. All right, now we're going to do unpaired electrons and the HEO. So this has 3 unpaired. And the HEO is the last thing we filled. So for phosphorus, 3p. It's not the last thing that's full. It's the last thing that has electrons. Next one has 4 unpaired. So arrows that don't have a partner. And the HEO would be the 3d. And then for tin, our HEO is the 5p. And we have 2 unpaired. I am going to add one more question here because several of you have asked me this question. So we can make it C, and that is how many valence electrons? So for valence electrons, it's everything after a noble gas. It's that simple. So our first one would have 5 valence electrons. Our second one we would say has 8 valence electrons. And for tin, we would have 14 valence. Again, you could say 4. So 14 or 4, I would accept valence electrons. Pages there. Let's keep going. The answers for 3 through 18 are down at the bottom of the page. That's what those symbols were down there, but we'll walk through them. All right, so we're back to this SPDF. I'll write it here so it's on the screen. SPDF 1357. So again, the SPDF is the subshells. So that's our subshell names. And the 1357 is the orbitals. That becomes the number of lines when we did the diagrams. So this is kind of like some of the questions. So 4D has, this is a comment for you. I sometimes ask how many electrons, and I sometimes ask how many orbitals. So underlining the key word, so I want to know how many orbitals in the 4D. It's 5. 5 orbitals. Here I want to know the electrons in the F. So I double that number. So 14. And then manganese, you underlining, highlighting, using a color. Pencils is perfectly fine. So manganese is Mn. So it is in the 3D. So when I said in what subshell area, that's the same as the HEO. It's just another way of asking the HEO, the highest energy occupied orbital. I like their acronym, but I'll write it both ways. But that's why I will be on Zoom. So if you have a question, you keep working, you can just click into Zoom. You'll be on our page anyway because you'll have the test opened up. Did you have a question, Shaylee? No.
No.
Okay. All right, the third principal energy level is the shell, has 3 subshells. So again, the shell number tells you how many subshells. After the 4D, we look on our periodic table. So the 4Ds are here from yttrium to cadmium. So we're in the P's, but we would be in the 5Ps. So that's what comes next. And then the highest in energy, the 4F, whichever one came the furthest along. So it's not that it's at the bottom, it's at the F's. Again, the 4Fs would be here in the 6th row. The 5Fs would be in the 7th row. All right. Maximum in any orbital is two electrons. Phosphorus, again, 2 answers I would accept. You could say 5 or 15. No, I'm sorry, phosphorus, it is 5. Sorry, it's 5. There's only one answer. And that's because there's no D's yet. So after the noble gas for phosphorus, after neon, there are only 5 electrons. All right. And then we actually did this one earlier, the generic NLX, but we're doing the halogens. So that's fluorine, chlorine, bromine. So we'd say NS2 and then NP5. So we're saying there's always 5 electrons in the P's. Their S's are full and then 5 in the P's. All right, name a halogen in the 3rd. This is chlorine. And I will be asking you to write the name to show you can go from the symbols to the name. Similar to oxygen, so family. Pick the one that you want to pick. So sulfur, selenium. Sulfur is usually spelled with an F, but European spelling is a PH. That's all right. All right, 2 3D electrons, that would be 3D2. That would be titanium. Gallium is here. Our staircase is there, so it is a metal. So again, on this side, periodic table, sorry for light, is the metals. Up here are the non-metals. This one's nicely colored. And then the metalloids are also known as the semi-metals. All right, cobalt will have 3 unpaired. So you could always draw it out. The HEO is all you need, that it would be 3D7. So cobalt, remember, is CO. Knowing your elements, being familiar with them will allow you to be much more efficient. If you're always dependent on trying to find names, then yeah, the time's going to seem crazy. But if you guys, you've all, you guy and gals, it's going to have Phillips are only guy. So cobalt, if you want to make a quick sketch, you can just do the HEO, which is 3D7, and see that you have your 3 unpaired. So we have 3 unpaired. Sodium is Na. So HEO is here in the 3s. And hopefully you can do this. If you're having trouble, please try to find time to come in. And again, Thursdays I'm going to start coming at 5. Thursday evenings I'm going to start at 5:30 because I know several people have a class at 6, so you can stop in because it is easier for me verbally to talk than emails. So if you're able to come to an office hours, please do. If you're not, you can try via email, but yeah. All right, number 18, we did not talk about this. It's barium. It is not barium. It is barium. Just so you have an answer, on the periodic table, as you move, the trends are always diagonal. The largest one is in the lowest corner. Why did I write barium? It's not barium. It should be strontium. My answer is wrong. There's a question I thought was on here. Oh, I know why, because yours I posted earlier. We're going to add a question down at the bottom. A different number, 18, but we'll make it 19. Which has a longer wavelength? This is from that video I made. Red or green? So we can walk through that. But there's that wonderful acronym, Roy G. Biv. I thought the question wasn't in the homework either, so I figured I'd add it here since I got the chance to make the video. And so red, this end is the long waves. So red, orange, yellow, green, blue, indigo, violet, it's the color of the rainbow. So I'm dressed in all purple today because I was needing short wavelength. And so short wavelength means high frequency. And so I needed a high energy color. So green would be the higher energy, red would have the longer wavelength. All right, any questions from this page? And then we have math. All right. So this study review that we're doing, it's not complete. I mean, I can't give you the whole exam. I have no idea where I'm going to go, but it's stuff that we have covered. So again, go back over your study sets, look over your post labs, the metric page in your lab so you feel comfortable with it, going back and feeling comfortable with the math. Extra credit will show up tomorrow, and that has more math practice. And you can absolutely check your answers with me during office hours or working with each other. So Sig Figs. Let's do a quick review. There'll be, well, we kind of when we do the math, but this number would have 5 Sig Figs because all the digits are significant because after the decimal. This will have 5 Sig Figs. So again, zeros after the decimal, after the non-zero number are significant. This would have only 4. This would have only 2. These zeros, if we change it to scientific notation, the zeros to the left of the non-zero are not significant. So our answer is going to only have 2 Sig Figs. And I don't remember my answer. All right, so we get 0.044. So let's say this was a question on the test. You would lose a little bit of credit. What's wrong?
Only 2 Sig Figs?
It does. I have 2 Sig Figs. The 0 doesn't count.
Oh, yeah.
Do you need to put it in scientific notation?
You know, I was looking to see that. I didn't specify, but let's go ahead and do that just because it's good practice.
And you need to put your measurement.
My units. Thank you, Katie.
Yeah, units. Sorry.
That's what I was looking for. So unit, nothing cancels out. These units shouldn't look as scary now that you did that density lab. And I know the math in that lab was, that's okay, the math in the lab this week, because I was in lab. So it comes out beautiful. It goes after the scientific notation. So grams per cubic centimeters is a volume. All right, in the next one, so 2 Sig Figs. Again, the 0 doesn't count. I did not specify scientific notation, so you don't have to use scientific notation. You're going to have to do it when you use the Avogadro's number, and you've all used it beautifully. All right, so let me just add up my number. So the calculator tells me my answer is 1851.3. It's like Katie said, okay, we want all the same, the unit grams, but the Sig Figs are not right. Why are the Sig Figs? And somebody new who's never answered me. All right, we're going to make like Tiffany and Brittany have to count to like 1,000 to Avogadro's number before they can answer. Does anybody else want to try? Katie's already
should
answered.
Be 4 Sig Figs?
No. So adding and subtracting, it's a different rule. And when you add or subtract,
the Sig Figs have to line up.
Sig Figs have to line up. So what should it be? I don't know who just said that. It sounded like Olga, but I don't know if it was her. You have to add a 0. When you add or subtract, it is the place value. This has 3 decimal places. This has 2 decimal places. This has 3. So we have to go to 2 decimal places. So you go to the shortest place value, to the 100th. That'll be like one question you'll see, and do it. The question also is, can you add them? Can you give me a unit? And then the Sig Figs. It's predictable. It'll be the most missed point on the test. That's why you can do extra credit, because you're like, it's all right. Gave it my best shot. And all right. These conversions will be there. These are the ones you need to use on the extra credit and on this. So let's go ahead and walk through it. These first 2 are not the moles. I know many of you told me you didn't like the moles, but the thing that's nice about the moles, there was always only one place to begin, and then pounds to gallons. We're working with 2 units. So you want to write them as a fraction, one on top of the other. And again, if you go back and practice, this is 454 grams. Bill Gates and I have been struggling a lot with his program. 454 grams to 1 pound. Yeah. All right. So my grams cancel. That gets me to pounds. I'm halfway there. Now the milliliters, we need to pull to the top. And using my chart, milli means gets the 1, 10 to negative 3 is liters. You guys have become really proficient at this. So the first week, everybody was like, what is she doing? How does this work? That first lab, if you go back and do it again, probably got it. And I think this class, you guys did pretty good. My other class was struggling a little. All right, and then we're going to pull the liters up. And I'm going to go to quarts. So if you go back and do some practice, that's my volume. And then my conversions here again, 1 goes with the US unit and the 0.946 is with the liters. You'll have to use my conversions. It's the one little piece of control I have. It's good. I have no control anymore. That's okay. We got, yeah. All right, Sig Figs. Oh, we don't have to add anymore. That just shows up one time. We do that. 3 Sig Figs. My numbers that I give you determine Sig Figs. So the metric to US conversions, they all have 3. Avogadro's number, we're doing with 3, except for Kaylee. which is fine, Kaylee. You can be that person. The periodic table we're doing with 3, except for Kaylee again. And the number I gave in the problem had 3, so my answer has 3. Hooray. All right, the next one, there's 2 pieces of information. So yeah, having colors, so I am not going to give you extra information. We're going to use both of those. So which piece do I start with and why?
The one with that.
One with 1 unit. Yeah. So 1 unit.
I stopped because you told us not to answer.
I know. I figured that's okay. It's so again, you guys know this. If you study, you're gonna do great. There was if you study, you gotta study. You've been studying. This is why I put a heart underneath so you don't try to put anything in that box or draw a unicorn or do something fun. You guys have been studying. That's why you've had a study set every freaking class. My colleagues are like, did you really do that to them? And I did. But you guys are prepared. You go back and do those study sets, you're going to feel good. You don't have to go back and rewatch the lectures. If there's something you're feeling a little rough on, go back and look at them then. And a lot of you have already watched them a second time. All right, I'm going to change hours. You can go hours to minutes, or you can go straight hours to seconds. If you do that, it is not 60, because there's 60 seconds in a minute. It would be 3,600. So go hours to minutes, minutes to seconds might be a good idea for many of you. And then this piece will fit in. And the seconds will go on the bottom and the 9.8 meters. The reason I didn't start there is that could flip upside down if you need it to. And, oh, good. I was thinking about the lab, and I have a question from the lab on here, so I will get to that. Where am I going? Kilometers. That's why I like to write down where I'm going, so I'm not there going, what do I do now? So meters to kilometers. Kilo gets the 1, meters gets the 10 to the 3. We punch it in. Back to the question that came up, I think it was Kristen caught my mistake the other day, so I'm pretty darn sure my answers are good. So make them punch them in if they want, or we can just all go along. It's like almost 8 o'clock. We're tired. All right. There's my molecule. Here's my, we'll do all different colors. So 4.44. And when you get to this, don't go, oh no, moles. Go, yes, it's moles. It's a celebration. I know what moles are. I can do this. And do something and just do a happy dance. And dress up. Like knit yourself like a really fun knot for doing it, so you can get a bonus point. You'll have to show up to show me your picture that you're dressed up. Because how else will I know? Maybe we all have to come for the first like 5 minutes before it posts. All right. We're going to pull molecules to the bottom to 1 mole. Oh, this is the one none of you ever like. This is the one where we start by dividing by Avogadro's number. You all like the next one where we go grams to molecules, but you never like the other way. A comment, I can't remember who, I know I said this to many people. When you divide, make sure you divide by the whole Avogadro's number, so parentheses, and then we're gonna go mole to the grams. So our 2 nitrogens and our 3 oxygens, so 76-ish. Use 3 Sig Figs. Oh, we're not done, because I do love throwing metric in there. So grams. This is, I think I talked about this. I know I talked about it with my other class. If you write micrograms like this, I know I wrote a comment on a whole bunch of worksheets. You're gonna get marked partially wrong because that is not the symbol for micrograms. So you either are gonna use the MCG or you have to learn how to make that dip for the micro. And micro is 10 to negative 6. And I'm pretty sure my answer is good. All right. Only that, and there's our compound. So we're going to start with kilograms, and we want to go to molecules. So let's get rid of the K because the periodic table is in grams. So 1 kilo is 10 to the third, and then grams to moles. This is the way you guys all love doing them too. This is, everybody's always like that. This is the periodic table number. And we got to add that up. So this is written because that's how chemists write it out. But if you want, you can change the formula. So it says, see, there's 3 carbons, there's 6 hydrogens, and there's 1 oxygen. So you can rewrite it. We'll get into formulas in like 2 weeks.
Me down at that point.
How I wrote it? Yeah, it's a way in organic chemist like to write stuff like that. So 58 grams, and then back to 58.0. A quick comment for you. Be a little bit cautious because we do a lot with carbon, hydrogen, oxygen, and nitrogen. But when you're taking a test, sometimes your brain remembers things funny. And so just double check. Oh yeah, carbon is 12. Oxygen is 16. And then we would do 1 mole and Avogadro's number. So 6.02 times 10 to 23. This was another question I wrote to a whole bunch of you on the worksheet. A whole bunch, like 3 of you. Make sure that this number has a unit. So some of you got a little casual with writing it. And then make sure your answer has a unit. You will get, it will be in scientific notation. So my E just means times 10 to the 25th, and that should be molecules. I think I ran out of room. I think my dragon got in the way. Make sure your answer, if you're using Avogadro's number, just double check. Do I need scientific notation? Like on the first number 4, the scientific notation, our answer ended up with no scientific notation. But on this one, usually when we use Avogadro's number, because of how enormous this number is, you're going to end up with an exponent just on your calculator. Tiffany, do you have a question?
Yeah, I've been writing the Avogadro number with 0.022. Is that a difference?
Oh, that's fine. No, you're fine. I said Kaylee likes to write it like that too. When I taught that video, I was teaching it's like triple dipping with 3 classes. So I recommended here, you can just go with 6.02, but if you write 6.022, I'm aware of that. And when you get to the answer, like my answer, I probably use 6.022. So if you use only 6.02, you might get 1.30 times 10 to the 25th. But I'm aware of that, and I look at how people's numbers are. All right, number 15. So you got a headache from the acetone. So 200 milligrams. There's the formula. This one has the extra step because I want hydrogen atoms. Atoms. And I'm starting with 200 milligrams of the whole compound. I put that decimal there to indicate we are going to have 3 Sig Figs. So all of these I started, kind of back to your question, Tiffany. My problems all only had 3 Sig Figs, so the answers are going to be limited to 3, but you can use 6.02 or 6.022 in the problem. So this is the one a number of you on the worksheet had a little bit of trouble with. Let's first get rid of the milligrams. And really, you just got to keep practicing, and you'll get it. Because there's really only a certain number of patterns. All right, milligrams cancels. I'm at grams to a mole. And this is of the whole compound at this point. So this was the question. So I have to add that up. Let me add that up first. All right, 216. The step you have to label fully is this one's going to have that extra step. So you don't want to just tell me that you have 1 mole and we're going to hydrogen. The number of hydrogens is the subscript, so to 28 moles. You will lose part credit. And there were a number of you who had the setup, but I said you had to label this. And so you labeled the H on top. The bottom needs to also show that you were working with, in these first steps, this full compound. And now you just pulled out the hydrogens. That 28, that subscript, is how many hydrogens are in there. If we did carbon, the number would be 13. Not 13 times 12, just 13. So we're not worrying about the mass anymore. We're at moles. We're just using, this is an exact number. And then 1 mole of anything is 6.02 times 10 to the 23. So like half of you got it and did it beautifully, because a lot of you actually came and saw me during an office hour to work these through. When you go from moles to atoms, it is always 1 mole. So that 28 only appears in that mole to mole step. Also, when you use the periodic table and go between grams and moles, it is always 1 mole. It just takes practice. Go back, just keep practicing. The notes, going back, if you're struggling still with moles, if you haven't fallen in love with moles, yeah, go back and do the pages in the notes. And like I said, you can listen to the video and then pause it and try the problem, and then and if you get stuck, or do a couple with me, and then see if you can do them on your own. And I did mention the last class, so we're going to do molarity now. We're going to have to find the answer for this one. So we have 120 milligrams of this and 12 fluid ounce of coffee. And I give us a conversion here to use. And I want to know, so Bill Gates doesn't know the term molarity. And so he always corrects me and decides we're doing a moral question. But it is correctly called molarity, like it is in the lab. And I've just made it a joke over the year, but his spell check just automatically changes its morality. And then I have to remember to go back. So we're calculating molarity. So we did this in the notes. It wasn't in the study set or worksheet. This is in your lab. So this is a good practice for the lab. Molarity is moles per liter. So on this problem, we're solving for that. So we need to start with 2 pieces of information to end with 2 pieces of information. So moles, even though many of you have said you don't like moles, you've got it. You have milligrams. So let's start with our 120 milligrams of our caffeine, right? That's going to be there on top. And then I need something on the bottom. I need a volume. And we got it there, 12 fluid ounces. Now, a comment about significant digits. Even though 12 is a whole number, fluid ounces is a measurement. This has only 2 sig figs, the 12. So our answer is going to have 12. All right, let's do the top part first. We got this? Do you guys want to try it first? I'll count like to 100. Let you try something. At least the top part you should be able to get. If you're watching along at home, you can try. You don't have to pause me because I'm pausing myself. Pondering what I need to tell you. I should add that up. Give me something to do. All right, let's go for it. I got a really tiny answer. That makes sense because it's milligrams. So milligrams to grams. We're going to use the periodic table. I gave you a chemical compound. A lot of these compounds do seem to have carbon, hydrogen, nitrogen, oxygen, because you may have noticed I like to write little stories with them because that's how my mind thinks. I wanted to mention some of you do the conversion where you say 1,000 milligrams to a gram, and that's perfectly fine. If you're comfortable doing it that way, great. I'm just trying to be consistent using the chart because most people are doing that and doing it very well. So 1 milligram, 10 to the third grams. And then we add up the numbers from the periodic table. So we would take carbon, the number carbon on the periodic table is 12.0 times the 8 plus 10 hydrogens plus 4 nitrogens times the 14 plus the 2 oxygens. All right, that gives us 1 mole. Now, normally we would go to Avogadro's number, but we are not because we stop at moles.
Brittany's saying that it's supposed to be 10 to the negative 3.
Yeah.
Milligram.
I don't know what I said. I know I said that you can use 1,000 milligrams, and I think I was on that. Thank you, Brittany. And then, so we got to moles. We are not using Avogadro's number, so you don't need to use that. All right. Let me write her name down before I forget. So, fluid ounces. Pulls to the top. And I gave you that conversion, 32 fluid ounces to 1 quart. And then at the top of the page, I gave you quarts to liters. And we're done. Grams canceled. I was just pondering, everybody like watches this at home. They're like sitting there going, why'd she write 3? And so thank you, Brittany. I don't know why I did. I got 1.7 e to negative 3. If you gave me that as your answer, I'm assuming somebody else did. You would lose part credit. A lot of you did this on your, not a lot of you, some of you did this on your worksheet. My answer needs, it's what Katie caught earlier, units. So you can either write your units as moles per liter, or you can just put the big M. The big M means molarity. I recommend you write it as moles per liter. But with that, I wanted to find something from your lab, but I'm not finding it now. Maybe it's this page. Yeah. The post lab, just some things to be careful with. So again, I'm going to write it as big M, but what I would do, and I talked about this, is instead like maybe cross it out and write 1.618 moles per liter. So when you see that big M, this is on the post lab. And again, we did a whole page in the notes last Wednesday, the very last page, and we were tired. It was this time of the night, and I did the molarity page. So I would recommend that you go back and look at that page, and you might want to watch the very last like 10, 15 minutes. This would be last Wednesday's lecture on moles. And so again, you have like two places. So you would start with the grams, and the molarity would be a conversion between moles and liter. You don't write it as a big M when you're using it in conversions and stuff. All right, that's all I got, unless somebody has a question.
For number 5, did you make the same mistake again with the grams over milligrams?
Oh yeah, I did, didn't I? I was on a roll. Did I do it every time? No, it must have been after my bedtime when I got to number 5. That's really interesting. I wonder what I said. Isn't that great? I recorded myself so I can see if I said it right.
Brittany did ask who draws the lead cartoons.
So I actually, oh, you guys didn't get the first lab. You had a different first lab. I had a student who was only in one class with me, and she was one of the best students I ever had, and she doodled. And I noticed her doodles. And she said nobody ever noticed her doodles before, her other teachers. And I asked her finally if she would illustrate all my labs and stuff. So it was like 5 years ago. My Sundays, my students were really patient with me the whole year because they knew what was going on. So Sundays, she would send me all the images, and I would have to cut and put them in. And so nothing, they didn't get anything ever till Sunday nights. And so not all of them are, like the dragon was not, or the unicorn. So you can draw your own unicorn or dragons or mermaid or Cookie Monster. But yeah, these guys, the Mr. Test Tube. Yeah, sorry, I can't follow the chat for some reason. My brain can't go there, and I apologize for my milligrams. All right, I'm assuming my answers are good though. One thing, I got one thing right. I'm gonna stop recording while I can.